Hello everyone, True Zero Emissions here. Okay, so let's go ahead and charge the Wolf King GTR. Okay, so I got these batteries charged. I'm just checking on these. Okay, that's gonna probably take all night. Okay, I'm gonna go ahead and charge the scooter. We're at 4%, 3%. We're at 4%, between 3 and 4%, and we're between 3 and 4%. Yeah, we apparently we went through a wormhole right here, because you see how fast we went. Not quite sure how that's possible, but you know, in particle physics, anything's possible, right? Anything is not only possible, anything is inevitable. Oh, let's turn a little more light on the subject here. There we go. Let there be light. That's what it's really about, right? Is let there be knowledge and wisdom shared. Let us see the light. Okay. Okay, so we're going to use this here. Let's see. Let me see how I'm going to do this. Okay, there's already one plugged in over there, so I'll use that one. Let me put this one, I'll put this back in here, because this is the one I keep with me. Oh, I also want to carry more things with me too. I want to carry a cell phone charger. I need to put more things in the bag here. I was thinking, you know, when I go riding, I should have a cell phone charger, because I want to use level 2 charging stations to charge the scooter. But if the cell phone were to die, I would not be able to sign up and communicate with the app if that's required, right? So I need to make sure I can always have power for my phone. Okay, so let's go ahead and pull the charger out. I just used the Roger charger maybe a couple hours ago, because my battery was totally out of power, and I went ahead and charged it up to almost 50% in a very short time, maybe half an hour. Okay, let's go ahead and set this here. That's an approximation I'm giving you. Okay, let's go ahead and unplug the soldering iron. We're going to unplug the soldering iron. It's hard to unplug something with the one hand. I don't know if this, oh, that's off. Okay, that's off. Yeah, I want the power off right now. Okay, so then that's the charger. Just set the phone down for 1 second. Okay, and then so we have that. Let's go ahead and put the charger over here. Let me think about this for a second. I'm thinking about taking the battery out while I charge it, because I want to keep an eye on the temperature of it. So I'm going to use this to help me see here, because the numbers are very small. So this can be programmed to have any code one desires. And the way it's programmed, if I recall correctly, is we push once it's on the unlock position, right? We push the pin in on the side and then put the code we want, right? That's the way that's done. So for now, I'm going to leave it like it is for the moment. And so that's unlocked. Okay. Take the battery out. Hang on a second. I'm going to set the phone down while I unplug this. I am inquiring about getting a second battery so that I could easily change batteries after a ride, or possibly even have a second battery strapped underneath the scooter, and then if, you know, once the one battery's depleted, I could just put the other battery in very easily. Okay, I just unplugged that. So I'm pulling the battery out while I charge it because I want to keep an eye on the temperature of the battery. That is a beautiful battery. It's not big enough though. I wish it was twice the weight, twice the size, twice the capacity. But I'm saying that, but I'm totally happy with this. I mean, it's not a small battery. I'm just saying I always want more, right? I always want more capacity, more range. That's just me. Look at that beautiful plug right there. Isn't that beautiful? Look at that. Okay, so let's go ahead and, okay, I'll leave, let me think where I'm gonna put this charger at. Put this charger, I think I'll put the charger right here. Apologies for setting the phone down so much. So I'm gonna set the charger here, battery here. This allows me to check, I can kind of monitor the battery closer with the, feel if anything's getting warm, and I can use my meter here, my thermal meter, to keep an eye on the battery's temperature and the wire's temperature, all that, right? Because I want to keep an eye on everything. Okay, let's go ahead and get some plugs out. So in here I have these plugs, this plug here. I really love the way they did this design. I mean, this is really, really just next level, and 100%. I mean, this was one of my favorite things, or was my favorite thing about the Dualtron Storm, and they just took this above and beyond. By the way, Ginger on Wheels made a video where his battery was a little bit loose. You may have noticed that. This one's not loose at all. This is, I don't know if his was a prototype or one of the first models. I don't know about that. I don't know what that scooter was. I just know that this one, everything's very secure, very secure. The battery fits in there really snug. So I'm gonna go ahead and, hang on, I'm getting ahead of myself. See, I gotta focus right now. So the charger's plugged in, but it's not powered on yet. So, okay, so let's go through this process now, okay? My apologies, I gotta focus right now. Okay, let's go through the process. So, we have the Roger charger. That lets me adjust the volts and the amps, right? But the volts are already set, but the dial could have been bumped. It was in the backpack, right? I'll check it again. Let's see if we need anything else. I got all that. No, I think we got everything we need. I wanted to watch the power going in. That's going to tell me how many watts are going into that battery. So, or going into the charger, and yes, into the battery. Okay, let's see. So, let me go ahead and turn on the charger. Let's turn it on by powering this up. Now the charger is charging the capacitors right now. That's why it delays. Okay, it has really good capacitors in there, right? Let's see what this says. So see how the voltage is where I left it last. Now it's dropping. But it was for a second. Oh, that's because my amps are down all the way. So let's go ahead and turn the amps in the middle. Let's go to the middle. So what I just did, by the way, I'm going to show you again. So the amps, I'll just do it. Counterclockwise is turning the amps down to 0, right? And then going the other direction is turning the amps up. I'm not going to turn it all the way up, but it stops around right here. Okay, so it does a little bit less than one full rotation, a little bit less, probably 90%, right? So it goes from this side around to here. So in the middle is like right there. Now when it's in the middle, that lets us adjust our voltage. So it's at 85.1 volts right now, which is good. That's where I'm going to leave it. That's where I'm charging this. Because Roger said in a video that if someone has a 100-volt battery, he would charge it at 101 volts, just 1 volt above the battery. So that's what I'm doing. I'm not telling you to do that. You have to do what you think is best for you by researching and studying this. And you could also ask Roger as well, but also you can still research it. Because in a way it's logical to set the charger at the same voltage that the stock chargers, they say 84 volts, right? These chargers say 84 volts. See? At 2 amps. That's the output. That goes to the battery, right? 84 volts at 2 amps. So why would I go 1 volt higher? And I don't know, because I'm just listening to what Roger said. But when I look in the book here, this is the Wolf King GTR user manual. It does say that I can use 2 5-amp chargers, which is 10 amps. That's a 10-amp charger. In 3.5 hours, I can charge the battery. So let's go ahead and do that. Let's go ahead and charge the battery at 10 amps. Now this dial is volts right there, and this dial is amps. Okay. Now before so what have we done so far? Hang on, let me close some doors because I'm making a lot of noise when I talk. What have we done so far? The reason I close the door is because the window's open in that restroom, and I don't want people out to hear me talking with the window open like that. My apologies for the interruption. Okay, so what do we have? Now it looked like that's taking 55 watts, right? Just to power these powerful fans and whatever this is doing right now, right? It's not even plugging into the battery, right? It's not plugging into the battery yet, but it's ready to go. Okay, look what we have. We have our 85 volts, right? So this is an 84 volt battery, so I'm going 1 volt beyond. And so the charger is plugged in, powered up. The amps right now are still at halfway, right? Approximately, because that's going to let me get the correct voltage, right? That's going to let me know the voltage, because if I turn the amps down, let's turn the amps down now. That's our next move. Our next move is to turn the amps down. Watch, counterclockwise. Ready? Here we go. That turned the amps all the way down, right? Until it stops, gently. See, I marked it amps. That's amps right there. And those are my notes I wrote here. See that? Roger notes. Now look what's happening now. Okay, let me do it again. I'm going to turn the amps down again. Okay, I'm going to turn it up. I'm going to turn it down. There it goes. So what I did is I turned this up a little bit and then down again. I did it again. So now that we saw the voltage dropping, I'm going to plug this in now. And on this scooter, the Wolf King GTR, it has a special plug. See the groove in it right there? I couldn't find this, so I just used plugs on the that came with the charger, and I just wired them in there because I like soldering. Now, when you solder things, always have someone do it that is experienced with that. And the most important thing is also the polarity, which is make sure plus goes to plus and minus goes to minus. That is extremely important. And you cannot be too safe on checking that. You can check that 100 times to be sure. I've done that too. And I've checked it on different days where I walked away from it, came back the next day, made sure it was still correct. Because sometimes when I'm tired, I can make mistakes. Okay, I can't see very well. Oh, it's kind of dark here. So this won't let me plug it in wrong, which is great. Okay. Okay, that went in. So they're both in now, right? So the charger is plugged in. Okay, and what I have here is we have the one plug right here, this plug, right? Which is an XT what? What does that say? I think this is XT60. That's the plug on the charger, right? And I connected the wires from both of these. Right, so the negative from that and the negative from that to this negative, and the positive from that and the positive from that to this positive. And on this plug, the flat side is positive. So that's the positive side, and this is the negative side, right? Let's see if it shows us that in there somewhere. I don't know if it shows us on this side. Okay, it may say that somewhere on there. I just know that this is negative, the curved side, and the flat side is positive, if I recall correctly. But I was very careful to be sure I did it correctly when I saw that. Okay, so what do we have now? The battery's plugged in, but the amps are still all the way turned down. Let's see what everything's saying right now. So right now the voltage I'm reading is 37 volts at 0 amps. Let's go ahead and turn the amps up now. So I'm going to turn the amps up by turning it clockwise, right? Clockwise. Right now it's all the way counterclockwise. It's turning it down to off, turning the amps off, right? So it's all the way off, and now I'm going to turn it clockwise, like the time on the clock, right? And I'm going to turn that just a little bit and watch what happens. Look, that's 1 amp right there. I just barely turned it. But let's go ahead and go a little more. Look at that, 3 amps. 4 amps. I was just fine-tuning it, just turning it just a little bit, trying to get 4 amps. Now there's a reason I put it there, 4 amps. There's a reason I did that. Okay, I'm darkening the screen so you can see this better. 4 amps, 63 volts. Now, four amps is what these two chargers are. These are the two chargers that came with the scooter. These two chargers together are 4 amps, right? Now, if I want to charge at 4 amps, the same as those chargers, I could do that, okay? I have that choice. Now, I'm not touching the voltage again. I'm not going to touch that voltage. That's very important, not to touch that voltage. If you want to touch the voltage, you have to start all over again and start from the beginning. But there's no reason to. The voltage is set. The charger's made, it's designed to bring that voltage slowly up to where it needs to be. So you can't touch it now. It'll throw everything off. It'll change. It would just confuse it. It would give the wrong charge if you touch the voltage. So we're at 319 watts, right? 319 right now. I'm going to darken the screen so you can see it better. So we're at 320 watts right now, okay? Now, what does the book say? Special thanks to Cabo. Right there, Cabo. Let's see if my phone will focus. It doesn't always focus very good. Maybe it needs more light. This is a iPhone 13 Pro Max, 13 Plus Pro Max, I think it's called. 1 terabyte. This is the Cabo user manual, Wolf King GTR. Oh, a 24-hour hotline. I just noticed that right now. I didn't even see that before. I'm definitely going to call that. You know what, everybody? Let's call them and ask them to make a seat for us, please. We need a seat. Let's call them and ask them for that. And ask them for the next model to have stronger regenerative braking at low speeds. As an option, okay? Because if you don't like that, you don't have to have it, but I sure would love that. Okay, guys. Okay, everybody. Let's see what the book says. Wolf King GTR user manual. Charging time. Use 2 5-amp chargers. 5 amp times 2. That's what that means. 3.5 hours. Customers are required to purchase 84-volt 5-amp chargers. Okay. Now, this is in the book. It's saying I could charge at 10 amps because 2 5-amp chargers is 10 amps. You add the amperage. That's how you do it. So right now we're at 4 amps, right? But we can go up to 10 amps. Let's see what this is at right now. So right now we're at 324 watts. let's go ahead and go up to 10 amps. So I'm going to turn this. Look, you can see I hardly turned it, right? Because this was just up here before, and now it's a little bit over. See that? Now I'm going to turn it a little bit more right now. Watch. See how little I turned it? Let's see where it's at. Look, I brought it up to 7 right there. 7.5. That little bit I turned it, right? Let's turn it a little bit more. Right now it's at 7.5. Let's do a little more. A little more. Ready? Okay, what do you think that is? I just barely turned it. Wow. Now we're at 8.6 amps. Okay, now I'm going to go ahead and turn it while we watch the dial here. We watch the screen. Ready? We're going to watch this. I'm going to darken it to make it easier to see. Let's go for 10 right now. So I'm turning very slow. There it is. $10.1. What a great charger. This is the Roger charger. R-O-G-E-R. You can look up Roger charger on YouTube. You'll see Roger himself teaching how to use the charger. And then there'll be links to, on some videos, you'll see links to how to contact him. There's an app that you use to contact him. So we're putting in 775 watts right now. Now everything's staying cool. Nothing is warming up at all at 10 amps. We'll keep an eye on it though. But the air is also on up there, as you can see. So that's on as well. That's keeping it cool in here. So it's cool inside here. But I think I can just leave these lights on all the time, 24 hours a day. Because I don't think it takes much power at all. So we're at 782 watts at 10 amps. Look at that, exactly 10 amps. Pretty good, right? Isn't that nice? I got it right there. It's okay if it's a little higher or a little lower. And if you prefer to be a little lower, that's fine. That's your choice. You can be a little bit below if you want to. Now I'm kind of curious of how high I can go where the battery still stays cool and not getting warm. Right? I'm interested in the limits. What are the limits? Now, I absolutely wish so much, I'm so focused on this, what I'm going to say right now. Wish might be the wrong word. I am so interested and passionate about understanding gbatteries working theories. These people, this company, this father and son started this company in their basement charging cell phone batteries. I'm talking about something different right now. I'm talking about fast charging and increasing cycle life by fast charging. Imagine fast charging being good for your battery, not bad for it, being good for it. That's what gbatteries achieved. Gbatteries. Okay, so G and then batteries. B-A-T-T-E-R-I-E-S, I think is the way it spells. But however you're supposed to spell gbatteries as one word, that's the word, gbatteries.com. And they share all the theory of what they're doing. And when I talk to electrical engineers on this, they totally understand it. And they're like, yeah, of course, yes, yeah. And I say, can you build something? And they're like, well, they're kind of busy. You know, people are very busy with their lives, right? But I am very interested in charging my batteries with the theory of gbatteries' approach to charging batteries. You know, and I'm just going to tell you what I think they're doing. I don't know how to explain this, but if I put together everything I've learned from Thomas Bearden in his books and in the Energy from the Vacuum science series, the collector science series, the very rare but can be found, people are finding it. You know, they're finding the material to study. Thomas Bearden said that we can pulse something, and he calls it negative energy. I don't know if that means when you pulse, it's automatically considered negative energy if you're able to pulse something before the resistance shows up, right? Can we send a pulse with a lot of energy, but before it creates a resistance, right? So I'm going to talk about the scooter for a minute. Remember I was talking in the last video, which isn't uploaded yet. It might take a day or so to upload. The last video I made that's uploading right now, I think it's an hour-long video where I just got back from riding the scooter. That video, I'm talking about the brakes, and I'm talking about two things about the electronic brakes. One is the electronic brakes where oh, I think I got to plug the phone in. I didn't realize the battery was getting low. I'm glad the video didn't start over. I'm actually surprised it didn't start over. So one, one second, let me plug this in closer to where I'm working over here. And hopefully I won't lose my train of thought. I don't think I will though. Okay, we're charging up again. That's the quick charger on this one, 20 watts. There's a cell phone that charges at 260 watts. I love that. I love fast charging. And yes, if I lose a little bit of cycle life, that's fine with me. I like fast charging, okay? I don't like waiting for the battery to charge. I want to use the battery. And if that means it lasts less life, that's fine with me. I want to use the battery. That's what it's for. It's for being used, not for waiting for it to charge. That's how I feel about it. So there's a 260 watt cell phone charger for a special phone, and I made a video asking Apple to please bring us that technology. I mean, Apple, you know, we're paying so much for these phones. I want fast charging. You know, I want 260 watt fast charging, which means the phone's full in 5 to 10 minutes. Now, I'm going to start experimenting with what I think gbatteries is doing, what I think Tom Bearden was doing, what I think all the great masters of electrical engineering and mechanical engineering were doing with fast charging and with energy. Tom Bearden talked about pulsing at 300,000 volts. 300,000 volts. Okay? And he called it pulsing with negative energy. And he said if you pulsed with regular energy, or not, he didn't say if you pulsed. He said if you charge something with regular energy, the battery would just explode. I think what he meant was if you were doing like a constant, I think it's CV, like constant current, constant voltage, that would make the battery explode. I think that's what he was saying. Now, if we do a pulse, though, before the resistance shows up, we can pulse something at 300,000 volts, but it's a pulse. And it's a pulse that's fast enough, it comes and goes quick enough that it doesn't let any resistance build up. I think that's how gbatteries is charging their batteries really fast. And I think, just my own thoughts, the reason that it sounds so complicated on their website is the same reason that Donald Lee Smith said that he did the same thing when he was getting patents. He said that he would, now I'm paraphrasing, but I understood him to say that he was making things so complicated for the patent office intentionally, like he was doing it on purpose, but really it wasn't complicated at all. But he's getting a patent and he wants to make it very, very complicated, and he wants to choose what they see and how they see it, you know, and still get his patent, right? Now, I'm paraphrasing. That's my interpretation. You'd have to watch Don Smith's videos. He has a whole lot of videos, and he has books. There's books that Rick Friedrich put out. Rick Friedrich put a book out that's all of Don's life's work, and even the emails of him talking to people and sharing information with people. So right now we're putting 800 watts in. 800 watts, everyone. Not bad, huh? And we're at 9.94 amps. Let's see how everything feels. Oh yeah, not even warm. Not even warm at all. Not even warm at all. Wow. Okay, let's see if we can put a little more power in here. So we're at 800 right now at 10 amps. Do not do what I'm doing. This is an experiment, okay? I call it tuition, okay? When I'm doing an experiment, whatever happens to my equipment or whatever I'm working with, that's the tuition, that's my education, that's my class. So if I burn something out, or the car breaks, or I burn the engine, or I burn the car down, like the car breaks, totally is no good anymore, that's the tuition for the experiment, right? That's the class, right? Okay, so this is making our own classes here. So let me go ahead and turn the power up a little bit. Okay, so we're at 13 amps now. 13 amps. And that is 1,044 watts. Now again, do not do this. Anything, everywhere you see on the internet is going to tell you, worst thing you can do not do this. Fast charging batteries is bad. But guess what? When G batteries, now again, this is traditional charging, right? So this, I understand what people are saying, that this can degrade the battery. Okay. I'm interested in fast charging. I want to see what the battery can do. I want to see at what power do things start to get warm. Because I don't actually understand how I could be putting 13 amps in here and the wires are staying cool, right? How is that possible? And the battery's staying totally cool too. 100%. Now, if the battery was in here and I was touching the metal on the bottom, do you see how that's not going to tell me the temperature of the batteries accurately? So that's why I took the battery out, because I want to be able to feel everything and see if there's any warm spots at all, anything even warm. And everything's doing really well. Even the wires, these little wires are not very big. I may change these wires to a larger wire someday, where I have to take the plug apart. I might have to cut it open here, like close to the, like I want to connect directly to the back of those metal bars that come out, and solder a thicker wire right to that, like a 10 gauge wire right to that. I also want to see how thick, oh yeah, that's it. I forgot, I thought this battery was charging through the scooter, but it charges right on the battery, so there's no other wires. So I was going to say, I'd like to know how thick the wires are that go from the plug to the battery as well, because sometimes those wires are really super thin. So we're putting in 1,000 watts right now. 1,049 watts. And we know that this takes about 50 watts to power, right? So that means we're putting in 1,000 watts into probably putting about 1,000 watts into the battery right now. And that's a watt hour. That means in 1 hour, it'll take 1,000 watts in an hour. That's watt hour. That's how electricity is. It's always by the hour, right? Unless we're talking about joules, which is watt seconds, right? So we could talk about those too, but right now we're talking about watt hours. So it's 1,000 watts in an hour, which sounds like so slow, right? Like 1,000 watts in an hour? What? That's why we're going to look at charging batteries in like 5 minutes, because that's what I really want to do. I want to build my own charger that is an expression and representation of what I've learned about G batteries fast charging in 5 to 10 minutes. Because they're fast charging batteries in 5 minutes. But they're not doing it like this. Okay, I think what they're doing is, they're doing what Tom Bearden was talking about. Now, G batteries is very selective and very specific about the way they use words to describe what they're doing. But they give us a lot of information. But what I see when I'm reading what they're saying, what I visualize what Tom Bearden was talking about. Those 300,000 volt pulses. And making sure you get that power in and out, or on and off, before the battery has a chance to resist the energy. And something I learned from electrical engineers is that current shows up before voltage. And to me, that means I think the current is what charges the battery, right? You'll hear people on the internet say, oh, well, there's voltage, but there's no current. You can't charge the battery. People just speak against everything that's being done, right? They just always do that. And it's always been done, so it's not anything new. But it's interesting because what are they talking about when someone says it? It seems like people could just be opposed to everything, right? Just opposed to any kind of thinking or any kind of achievement or any kind of something that people are working on. And but what is the basis for it? I don't know. You know, like, what does it mean to say that? What is the basis for it? Like, what is the purpose of, like, what's the meaning of saying something cannot be done? But if we look at what's being done, it's being charged. We're charging a battery in 5 minutes, right? The G batteries is, and I think they're doing it with high voltage pulses. So let me think about this. If I'm pulsing something, right? What's better, a square wave, a sharp square wave, or a smooth sine wave, right? I mean, a smooth wave or a sharp wave, right? So I think a sharp box wave, a sharp, like, pulse, like boom, just a quick sharp pulse would be ideal, right? Deliver that current, right? And I think really high voltage is ideal too, like 300,000 volts, Thomas Bearden said. Now, okay, this is a 84 volt battery. So my thoughts are, watch the voltage of the battery. This is what I want to do. I want to charge this battery at super high. Start out low voltage, start out with lower voltage and just work my way up. But let's say I'm up to 300,000 volts. Let's say I'm at 300,000 volts and I'm pulsing it at what? What's a good pulse? How many times a second would be a good pulsing, right? Hundreds of times a second? Thousands of pulses per second? Hundreds of thousands of pulses a second? Millions of pulses per second? I don't know. G batteries, the father and son, when they started in their basement, if I recall the story correctly, when they started in their basement, their goal was not fast charging. They didn't say, let's fast charge batteries and see how fast we could charge a battery. If I recall correctly, that was not the goal. They just wanted to see, can we charge a battery in a different way? Rather than the, I guess, constant current, constant voltage. I think I'm saying that right. Look, this is holding at 13 amps, everyone. Again, yeah, if the comments were turned on, I'd get a million people going, you can't do that, you're ruining your battery. Guess what? This is an experiment. Okay? This is an experiment. This is my experimental scooter. Do you see the wolf box on there? That's an experiment. Do you see my tiny LEDs, Tiny's LEDs? That's an experiment. Everything's an experiment. This channel's an experiment. This video's an experiment. So, let's see what the voltage is doing. See that voltage? It's moving. I like that it's moving though, I like that. The wires are absolutely cool still. Not even warm. The wires are not even warm. Let's see how the battery feels. I felt so bad when someone was describing their experience of they bought these really expensive fast chargers and they weren't even getting the rated power. Like it said 8 amps or 5 amps. They had two different chargers and both of them were giving less than that. The 5 amp was giving less than 5, the 8 was giving less than 8. And I thought, wow, I'm so glad that I can adjust the amperage to what I want it to be. If I want 8 amps, I have 8 amps. I just turn the dial. You know how I learned about this charger? I was having a conversation with Cameron. For those of you that know my friend Cameron, by the way, Cameron just ordered a, I wish we made a video about this. Segway is such a great company. I'm so excited for Segway. My friend Cameron, he loves the Segway GT1. That's his favorite scooter on the planet. And he bought the scooter on sale. I think it was on sale recently in the past week. It was on sale, and Cameron bought the scooter, and then he found a code that took another $200 off the scooter. And I was just like, oh my gosh. And I thought about buying one, you know, because the price was so low. It was so good, such a good price. So it was already on sale. Then there was like another coupon on top of that you can use. And it just makes me really like Segway, because Segway is a good company. They're great. Segway, I would like to see Segway build a enclosed, you know, where you can say, because Segway knows style. They know ergonomics. They've mastered ergonomics, they've mastered style, they've mastered quality control, right? They've mastered customer service. They've mastered pricing and keeping the product moving. See, I don't know for sure, but I don't know why they lowered the price of the scooters, but did sales slow down and so they lowered it? They said, we're going to keep these things moving. I don't know if that was the case, or they're just doing really good and they said, hey, let's give people a sale so more people can afford this, right? And I just think that's wonderful. But those of you that have been watching my videos know that when I rode the Segway GT2 that I had, I need the front suspension to be a little softer for me when I hit. Now it's perfect, the suspension's perfect, except when I hit like a 3-inch tree root pushed up the cement, and it was like hitting a brick on the road that was cemented to the ground. That's what it felt like. I hit this thing so hard, and I hit that same thing on this scooter, on the Wolf King GT Pro, which is similar to this, and it totally absorbed it. Maybe it's because the way the shocks are, I don't know. Whereas the Segway GT2 was it transferred more of the energy to my hands, and both my hands came off the grips, even though I was holding on tight. But aside from that kind of bump, which is unusual, right? That's an unusual kind of bump in the road. The scooter's great, and I was tempted to get one again, to get a GT1 at that greater price. But I want to see what Segway, where they're going, and I would really love to buy like a micro mobility vehicle, something like, I could see Segway making a micro-sized version of the Aptera Motors car, and I mean something really tiny, like literally you could bring inside the house. And it's like seats one, or it might seat two, like one behind the other, and it's really, really small. And maybe it just seats one, who knows? But it's aerodynamic. It might have 3 wheels. Maybe it has 2, but I think it'd be neat if it had 3. It might be the size of like a mobility scooter, just regular mobility scooters. They have 2 wheels. They have 3 wheels or 4 wheels. It might be that size, but it'd be enclosed. I'm so excited for that kind of transportation that I haven't really seen here in the United States of America. I haven't seen here much of that. Now in Europe they have all kinds of enclosed micromobility, and they have very stylish, futuristic, aerodynamic. I love it. And people go, oh Joseph, well America is like 10 years behind in tech, like 10 years behind. But I see no reason that we can't be 10 years or 20 years ahead. There's no reason to not be. We just use our imaginations, work together, collaborate, and make it happen. Just do it. Because people are buying these scooters to replace their cars, and a lot of people get rid of the car and buy the scooter. I've met a lot of people at Voro Motors just sitting in the waiting room when I'm ordering parts and stuff, and getting scooters and buying scooters and stuff like that. And I've met people just talking to people, because people are so friendly, they're so excited and so enthusiastic about what they're doing. And I've met people that say, yeah, we got rid of the car. It's gone. The car's gone. This is our new car. This is our car now. This is our transportation. I don't think they call it their car, but it's their transportation. I'm going to check temperature again. I'm just going to go by feel here. Yep, we're real good. Not even warm. And the battery is room temperature as well. And we're at 13 amps. Now, I'm not telling you to do this. And this kind of charging, which is just traditional charging, this can decrease cycle life according to what people say on the people that know more than me. So we're still at 1,000 watts, which is good. So it's going well. So let's see. This is a 2,500. Oh no! Listen to this. This is a 2,500 watt-hour battery, right? That means we can draw, when it's full, I can power something I can power something with that battery that takes 2,500 watts for 1 hour, right? So the rating, let's say we have a heater, because heaters I don't think they go this high. They usually go to 1,500 watts or 1,800 watts, right? But let's just hypothetically say we had a heater that was 2,500 watt heater. That would mean, if it said that on the back, if it's a 2,500 watts, that would mean that in 1 hour, because it's always watt hours, right? Unless it specifies otherwise, but I think it's like always watt hours. That would mean that heater, to work at its full capacity, the proper, the tested heat, the UL rated, everything that it's been tested for, that it would take 2,500 watts in 1 hour. That means it would deplete that battery in 1 hour exactly. That battery would be drained totally to 0% in 1 hour, okay, to power that 2,500 watt heater, because that's a 2,500 watt hour battery, right? Now, if we're putting 1,000 watts in there, it's always watt hours, right? So that's 1,000 watts for 1 hour. How long would it take to charge that if we're putting 1,000 watts in it continuously, right? 2.5 hours at 13 amps. That sounds pretty good to me. But, I want 5-minute charging. I'm going to do it too. I'm going to get 5-minute charging because, why? What do we know? Set your mind to it. You can achieve anything. Set your mind to it. As long as it causes no harm, okay? That's very important. But I'm not causing harm. I desire to learn. I desire to create. I desire to share. I desire to learn and improve. And I desire to have faster charging. Gbatteries has already done it. If no one ever had done it before, then that would be probably a greater challenge and more to risk. But wow, Gbatteries already did it. They already did it. 5-minute charging. They charged the Xiaomi M365 scooter, which at the time they did this, that was my first scooter. It was an M365, and Cameron and I both loved that scooter. We thought it was the greatest scooter on the planet, even though I was getting a flat tire every week on that scooter. And it was so frustrating. And I asked the bike shop if they could help me change the tire, and they said they recommend putting solid tires on it. And I found out about the honeycomb tires, which felt just as smooth and cushiony as an air tire. But some people are so traumatized with the solid tires by getting the wrong kind. They get like the real hard rubber, and it just is so jarring to ride, and it's so uncomfortable that they don't ever want to look at a solid tire again. It's really important to get the soft solid tires if you want a smooth ride. So it's called solid rubber, but it's honeycomb. That means it's all got the cutouts, the air cutouts in it, big ones, that lets the tire go like this. It lets it cushion when you're riding it. They even have tires that are rated by air pressure. Like this solid tire feels like 50 psi. This solid tire feels like 80 psi. This solid tire feels like 90 psi. This solid tire feels like 25 psi or 30 psi. I've even seen that. So there are a lot of choices. Okay, we're still putting in 1,000 watts. And remember, that charger itself takes about was taking 50 watts just to power it. So, now right now there's no need for me to fast charge, right? No need, really. Or is there? I'm not going to leave this charging by itself. I'm not going to walk away from this. So since I'm going to watch it, I feel like being right here with it is preferable to me. So if I'm going to be right here with it, watching it closely, I do prefer to charge it quickly, so I can do other things after it's done charging. But if we can pulse this at 300,000 volt pulses before the resistance shows up, now how would I know if resistance is showing up? Here's what I would look for. I would look for the charge voltage of the battery increase, if it's increasing or not. Am I getting the charge voltage to increase, right? That's what I would notice. I would notice that's my indicator. Because if we're pulsing current, a regular meter can't read that. A regular amp meter is not going to read that, right? My regular amp meter is not going to read a pulse, right? I don't think that's going to read a pulse. It's not made to read a pulse. It's made to read a continuous resistance, right? But that's the least efficient charging there is on the planet. And it's the worst thing we could do to a battery. So we want to talk about what's good and what's bad for a battery. Traditional charging is bad for the battery. This kind of charging, we're forcing the power in constantly. I'm going to say it this way. It doesn't harm the battery as much as this kind of charging, pulse charging, I'll call it pulse charging, is not as harmful to the battery as the continuous current charging is. Now, for many years, many people failed at pulsing charging, right? So it got a bad name, right? That would be equivalent to many people trying to fly the first airplane and so many people failing that anyone that tries it, after many, many years of people like dying and going crazy or whatever happened to them, they lose their mind or they just, they didn't take care of their health or whatever happened, that it gets to the point where anyone that even thinks about doing such a thing as try to fly is considered completely insane and should be hospitalized for insanity for wanting to harm themselves. I read articles like that from back in the day when no one had flown yet successfully. And they were trying to push this thing. There were people, I don't know if it was people, organizations, or everyone, there was a lot of people that were against, I'll just say, innovation. They were against moving forward, right? But people didn't give up because that's built into us, right? Our very existence. It took the universe 14 billion years to come up with us. So we are, I don't know if you call it the culmination of a lot of creativity that happened, that the universe did. A very wise universe, right? Very wise. I think Leonardo da Vinci said the universe will always, nature, I call it the universe or nature, will always take the most efficient path to achieve her needs or what she needs. Yeah, nature. Nature will take the most efficient path to create, to get those needs met that nature has. And we can replicate nature that way, right? So if constant charge, constant voltage, I may be saying that incorrectly, but it's that constant pressure is warming up a battery. But if we can find a way to pulse it, right, where current's getting delivered, voltage is increasing, and we're not getting the hot battery. That's, I think, if the battery's not warming up, is an indicator that we are not causing, if I say it that way, resistance in the battery, right? So why all these people saying pulse charging's a scam, it's a hoax, it's nonsense, you can't do that? Why so many people saying that when we know if we set our mind to something, it can be achieved? And why focus on the failures? There's entire philosophies of life where people say we are not going to ever talk about the negatives, the failures, the things that we did wrong. We're not going to ever bring that up. Like it doesn't even exist. We're just going to acknowledge and talk about what we need, where we're going, right? What we need, where we're going, what we need. I need fast charging. I need 5 minute to 10 minute fast charging, and I need the battery. I need the battery to not lose cycle life by fast charging it. Imagine fast charging this battery in 10 minutes and doing that every single day, and the battery having more cycle life than if I was to slow charge it, right? So let's say I had 2 scooters, and one scooter I charged every day, the same exact scooter. One scooter I charged every day slow with the charger that came with the scooter, and then the other scooter I charged with the 300,000 volt, what I'll call negative energy, which is just a pulse. I think negative energy just means, in my own thoughts, I think negative energy just means that we're able to deliver the pulse before the resistance shows up, right? Because it's such a puzzle to understand what Thomas Bearden is talking about. People say they read his whole book and studied every word he ever said and ever wrote, and they don't understand one thing he said. And I'm definitely one of those people. But what I'm noticing I'm doing is I'm saying, let me stop putting that constant pressure on myself to try to figure out what he's saying. And rather than do that, let me look at the big picture, which is, what is gbatteries doing? What is Thomas Bearden doing? What is Rick Friedrich doing? What is Gerard Morin doing? What's he talking about, right? On YouTube, he has a lot of videos he shared. What is John Bedini doing, right? He shared a lot. John Bedini has books. He's in the Energy from the Vacuum series, Science series, the Collector Science series. What is all these inventors, all of them? What are they all doing, right? Anyone that shares their work, what are they doing, and how does it relate? And Donald Lee Smith, Don Smith, right? Donald Lee Smith. Now look, I know a lot of people have replicated his systems and achieved it. My request to you is, how can you share what you think is happening, right? Because people make these videos of showing it working, right? Well, Rick Friedrich calls that trying to prove something, and it's important to not try to do that. Rick, that's my interpretation of what Rick's saying, is it's kind of like a waste of time. Never try to prove anything. It's very important. Never try to prove anything to anyone. What we want to do is focus on sharing. It's who are you focusing on? Are you focusing on trying to prove something to people that are just going to, no matter what you do, they're going to say, do this, try that, do this. Well, you didn't do this, you didn't do that. I mean, you're going to be running in circles. You're going to get really dizzy. I get dizzy watching people do this. Or focus on the people like me and the billions of other people that are trying to think about how to think and trying to think about how to conceptualize what may be taking place and talking about the parts. Maybe one video talks about this part, right? And another video talks about the next part. And you just kind of, when you look at everything together, it starts to create an image of what may be taking place. But it's leaving it open to the possibility that it could be something else. Because do we know for sure what's actually happening? I don't know if we do. I mean, Don Smith spoke in a very confident way about what was taking place, but I don't know. I think he was still open to what was happening. Like he had a lot of knowledge. He was a master at putting the pieces of the puzzle together. He would research these different areas of knowledge. I mean, different, how do I say this? Don Smith would research and experiment continuously, and he would bring together information as it related to the focus, what he had his mind set to, right? It seemed like his mind was set to efficient use of the energy that's in the environment, right? Efficient use of it. Now people can say, oh, there's no energy there. Well, it's potential energy. To say there's no energy in the environment would be to say that that's not energy lighting my bulb, because the energy in the environment is what's lighting all these lights, right? Those lights, if I understand it correctly, are not powered by a battery. If I understand Tom Bearden correctly, and I can't say that I do, but it seems like he's saying the battery doesn't power the lights, and just like the power company doesn't power that light. But the power company sends a signal that activates the energy that powers the light here. So the energy here powers the light from the signal sent to us through the wires from the power company. That's what we pay for, right? So we're paying for that signal, I guess. Now the battery here is storing energy that's powering this light. The battery's storing energy, but what's making this light light up? I think it's energy in the environment that's I think the battery is a catalyst that activates the energy in the environment to make this light turn on. I think that's what's happening, but I don't have an image for that yet. I can't see it. I just have information, like pieces of it. But I think the experiment is very important, the experimenting. And that's why I want to keep, so we're still room temperature here. And even the charger is very cool. someone was saying, or a few people are like, oh, the fans are so loud. Well, you know what, if you don't want fans, you can use the stock chargers, and those things get hot, really hot. In fact, I put fans on those. That's why these fans are here. You see these fans? Those two fans are really powerful, and I put them on full power when I'm charging with chargers that don't have fans, because they always get hot. All chargers get hot, all of them. All these chargers, even the XVEs. That XVE charger, that thing will get so hot. That's the charger that came with the Nami Bernie Viper, right? It came with those two chargers. So fast charging, pulsing. Now, does that mean I can just can I take an existing circuit, right? Like this pulse width modulator, right? Now, John Bedini said pulse width modulation is very, very important. Now, pulse width modulation, he said that's where it's at, right? You see that right there? That's a motor controller. That's made to power a brushed motor. And if I understand correctly, it's called a pulse width modulator, right? So if I power that with a battery, and I connect the output to a battery, right? Would that charge more efficiently than these chargers? I don't know. I really don't. Can I increase the frequency of that pulse beyond what it's at? Can I increase the frequency exponentially? Can I adjust the frequency, right? And for those of you that were following Robert, the gentleman that was in some of my videos, he's so busy, maintaining the world, because he's a maintenance man. He goes and maintains electronics. But, even though he said he wants to experiment, it doesn't seem like he has time. So to me, I don't have time not to experiment. I have to experiment. To me, it's like breathing, right? But that's how I am. When I set my mind to something, that's my air, I breathe it. I live and breathe it. As you can see, I think anyone that's followed my channel, that's followed this channel, has seen it's not my channel, it's our channel. That's one thing for sure. Okay, it's all of our channel. Just like it's our world, it's our universe. And I think everyone else in the universe would say the same thing to us. They would say, yeah, it's all of ours, And I think that seems to be a universal truth, or universally acknowledged. Yeah, the battery sealed really well in here. It didn't let dirt fall in. I'm really surprised. It sealed really good. What I haven't figured out is, and it's partly because I can't fold the scooter with all this stuff on here, but I haven't figured out where that hook goes. I'm gonna ask some. If any of you have a Wolf King GTR, please fold it so that I can see where the hook goes. I really want to see where that hook goes. I don't think it goes back here. Maybe it does, though. Maybe it hooks onto the frame to there or there. But it looked like people were hooking it here somewhere. I just don't see where the hook goes, though. Because there's nowhere. I don't see anywhere for it to hook onto here. I just want to know. I'm not going to be hooking it because the bag's here. So I'm not going to be doing that. I'm not going to be folding this right now. Although I could put the bag in front. Hang on a second. How could I do this? I think there's a way to do it where I can still fold this. This bag can go in the front, and this bag can go down here, and that would leave this space open. That's a possibility. I don't have any need to fold the scooter right now, and I don't necessarily want to need to fold it, I love how stable this is. I would not want Cabo to change that front end to make it easier to fold and then lose that stability it has. I love the rock solid stability that it has. It's so stable. So look, we're still at an absolutely exact, look how good this charger is. It's at 13 amps exactly still. Now look at this though, the watts has gone up. Oh, the watts has increased. I just push these two buttons. I know that makes it light up again. So I just keep pushing them until the watts show up again. I don't know what these, let's see what these numbers, I don't know what these numbers mean. This has been plugged in for a while, so it's probably showing some numbers from other things. But it's putting in 1107 watts. We're at 74 volts now, so we're 10 volts away from being full. And this is absolutely not even warm at all. Not even warm. And I'm at 13 amps. That's 2 amps away from the maximum this charger can do. What would be nice is to modify this charger to charge the way that G batteries are charging batteries, right? To charge that way. When I spoke to G batteries a couple years ago, and they're just beautifully wonderful people. They're just absolutely wonderful. And when I communicate with them, they, what was my train of thought? I lost my train of thought. Well, they're excited about what they're doing. I can tell you that. They're very excited about what they're doing. But they said they agreed that the only thing that will bring their technology out, because anybody that wants to know why it's not out yet, is because we're not asking for it. It's really strange to me to see people not talking about that company, because that company's real. What they're doing is real. They've been doing this for over 15 years. They proved this over 15 years ago. They've been proving it over and over and over, meaning they're doing all the tests. They've just repeated and repeated and repeated. And it's like, what else do you need? I mean, they're working with a lot of companies, but my friend Will looked into them, and he said that it just looks like there's a lot of involvement from a lot of companies, and that can cause it to be more difficult to bring out a product when there's a lot of people involved, if I say it that way. And that's my interpretation of what Will was saying. Will's a business person himself. He's a business major and a master of thought, absolute master. And I hope Will and I can work together on projects someday. So we're still charging here, but as you can see, imagine if this was charged in 10 minutes. G Batteries is charging electric vehicles. You know how big an electric vehicle is, right? It could be any electric vehicle. It could be a Tesla. That size battery, right? That big battery in there. I mean, the big overall battery, the capacity of it, in 10 minutes. They can charge that in 10 minutes. Okay? They've done it. They've charged electric vehicles, and they're just continuously testing this, continuously. There's tests always going on, ongoing. So, I mean, I feel like what I may have to do is just start from the beginning and just literally start with cell phones. And I had a bunch of cell phones I was saving for this test, and I got rid of them. I need to collect some cell phones again, because I want to do some testing with charging batteries. I guess it doesn't have to be a cell phone battery. It could just be a cell. It could be like these lithium cells. I could do it with one of those, and just do it like outdoors in a enclosed box. So if it blows up, it's not going to hurt me or hurt anybody. But charge it at this high potential charging of pulses, and see if I can charge a battery fast. And with existing technology, with a pulse width modulator, what if I take that pulse width modulator and run the positive through a brushed motor and then to the battery, right? So when I turn that power up, it's sending the pulses through the motor and then going into the battery, right? Maybe that would help. I don't really know what that does, but the imagery is there because I've studied Tom Bearden, I've studied John Bedini, I've studied Rick Friedrich, I've studied Gerard Morin, I've studied all the different thousands and thousands of people on YouTube that are experimenting, that I don't even know everyone's names, And I have these images of try this, try that. Now here's the thing. If it works, am I going to be able to tell you why it's working? I'm probably not. But here's the thing. I just want to ride my scooter and charge the battery in 5 to 10 minutes. So if I can do that and it's not making the battery cycle life degrade, I'm happy with that, you know. Goodness gracious, when I first started experimenting, it seemed like everyone was telling me everything I talked about. People would just say, get a patent, get a patent. This is the people that I was surrounded with in the beginning, because everyone was telling me, get a patent. I'm like, sorry, this is just something people are doing on the internet, experimenting. There could be a patent on it already, I don't know. It's like sometimes people can have a hard time relating to the idea of just experimenting for the joy of learning. And I think that's important to me, is that this is about learning and seeing what happens when I experiment and try something new. You know what I mean? What happens if I try this? What happens if I try that? That's what it's about. It's about seeing what the experiment does. It's not about how can I patent this? How can I make money off this? How can I, keep this a secret? How can it just be mine? I mean, that doesn't make any sense to me. What makes sense to me is first doing the 5 to 10 minute charging, right? Get it working. If it works, then everyone can find their own way to change it just enough to get a patent on it and then sell their own version of it. I mean, that makes more sense. Because look, anyone that's hiding an idea, this is a thought I have. I get it, though. I understand. In a way, I get it. But I don't think it's the way I don't think it's the best approach, because let's say this. Let's say what I'm talking about is, let's say someone has an idea and they keep it to themselves, right? And let's say it's, we'll just say it's fast charging a battery, right? Fast charging battery, they keep it to themselves. They didn't talk about they didn't share how to do it. And they get a patent and they sell the idea, and then a company owns it, and maybe they'll come out with it someday. They probably will, but who knows when. And meanwhile, no one else knows how to do this. Versus, listen to this now, versus sharing the fundamental theory of how you do this in some simple way so that everyone can do it, right? This is just a thought. I'm doing a thought experiment right now. This is a thought experiment. Let's say that there's a way to charge. Let's say it's just what I said. Pulse width modulator, which is a motor controller, powered by whatever. It can be powered by, the voltage has to be higher than the battery I'm charging. I know that. So if I'm charging an 84 volt battery, I have to have more than that going into that, right? So first of all, it has to be able to handle that high voltage. So it'd have to be able to handle probably like over 100 volts. And then let's say I power that with like, let's say I power the pulse width modulator with, let's just say a 100 volt battery, right? Let's say I have a 100 volt battery and I power it with that. Or I use a step up, DC to DC step up or something, where I can step the voltage up. So I'm using the same voltage battery, like 84 volt battery, because I have another one of those. Oh, I just thought of how I could do it. I could actually run two batteries in series. I could run an 84 volt battery in series with like a different voltage battery, and those two voltages will add up. I think I could do that. Don't do what I just said. I don't know if that's safe. I would do that very carefully under safe conditions with full gear on and mask and shields and gloves. And then I would power my pulse width modulator that could handle the voltage. It had to be rated for that total voltage. And then let's say the negative wire goes to the battery directly, and let's say the positive wire goes through a little, like a motor, right? Let's say like a high RPM motor. The positive goes through that motor to the battery. Now, if I understand correctly, and if I recall correctly, that motor will spin when I start turning the power up on the pulse width modulator. When I start turning the power up, that motor will spin, even though it only has one wire going through it, the positive, right? And that could be vice versa too. The positive wire can go straight to the battery, positive, and the negative can be split and go through the negative wire can go through the brushed motor and into the negative of the battery, right? If I understand correctly, and if I'm saying this correctly, please confirm this for yourself. That would work too. So those are two different tests that could be done to see if they have different results. But let's say we turn up the power and got the battery charging, and seeing if that battery can charge faster, seeing what the voltage does. That's what really counts, right? It's not measuring the amps that are going to it. It's what is the voltage doing, and how quickly can we get the voltage to be full or close to full, like 80%, right? Let's say 80%. how quickly we can get the voltage to go to 80% and stay there, like stay at that 80% or close to it, not drop all the way back down, right? And then use the capacity without things heating up. That's what I would be looking for. So now I was thinking of putting that I have a really big 84 volt battery underneath this table. For those of you that have been watching my videos, have recently seen that in the past week, I think. I was like, oh, I forgot I had this battery, and I bought that battery for experimenting with, to use for, high voltage experiments, and potentially for a range extender for a scooter like this. So if I strapped that 84 volt battery underneath the scooter with like these big tie straps for like motorcycles, strap it around the scooter, although I don't know how I'd do that without damaging these lights. I could probably go behind this though, in here. Yeah, I could do that. I see a space right there. It goes straight to the ground. That would work. See that? The strap can go straight through there. And it shouldn't damage this wire either, because my video camera wire is down there too. But it's below. So as long as it didn't touch that wire, and I could move that wire if I had to. So I can have the battery underneath there, and then let's say I do what I just said. I have the positive going to the positive, or I don't know whether to do the positive or negative, but let's see. I guess we could have the negative of the battery go directly to the negative, and then the positive going through go through a motor that I just have sitting somewhere, right? Now, just for those of you that are familiar with this, or not familiar with this, I'll just review real quickly, that the idea is that motor, when that motor spins and the energy is transferring from one battery to the other, one of the requirements, though, is that one battery has to be higher voltage than the other. It has to be, or it won't move. It won't spin the motor, right? It's like how you have to have unequal amounts of water pressure, right? To get water to move one direction, there has to be a difference in pressure. So that's what voltage is. If we think of it as pressure, there has to be a difference in voltage. So probably at least 12 volts, I'm guessing, or at least a few volts, enough to make that motor spin well. Now, so let's say I run, that big battery and then plus the little one in series. In series would mean, so between the two batteries, I'd have one positive and one negative connected together with the two batteries that I'm adding to the scooter. And then on the remainder, positive from one battery and negative from the other, are my circuit batteries that go to this scooter. So now the negative is going to go from this series set of batteries, the negative go to this battery directly, and then the positive from this set of batteries would go through the motor, through a brushed motor, right, that has two wires on it. It would go in one side, and then the other wire coming out would go to the positive of that battery. And then, wait, I'm saying this wrong. Oh my goodness, let me back up. I'm trying to skip the pulse width modulator. See what I just did? Okay, so now, the way I would do it is pulse width modulator, my two batteries in series, we have a positive and negative connected together of one battery to the other, right? One battery is positive, the other battery is negative together. And the remainder, plus from one battery and minus from the other battery, those would go to the pulse width modulator, right? Then the pulse width modulator negative would go directly to that battery's negative, and the pulse width modulator's positive would go through the brushed motor into the positive of this battery. Now, I can turn the power up on the pulse width modulator, and it would make that motor spin, and it would be charging this battery at the rate, this is the way it's said, at the rate of powering the motor. So the more load that's on that motor that's spinning, that's free spinning, is the more power the faster that battery would charge. But if I just had that thing running freely, it would be kind of giving it like a trickle charge, right? And I'm kind of curious what that would do while I'm riding the scooter, but not when the battery's full. It has to be low. I have to get it down a bit because I don't want to overcharge it. That's very important. We never, ever want to overcharge a lithium battery. Now, what am I talking about? Because I was just telling earlier about 300,000 volts, right? But we're not talking about constant voltage, constant current. We're talking about pulses. So when we're talking about pulses, everything's still cool, and that charger's cool too. That's why Roger has those powerful fans on it to keep it cool. So when we're talking about pulses, 1126 watts. When we're talking about pulses, that's completely different than a constant pressure, right? Just like a really heat causing resistance in there. Like the battery just doesn't like that. Whereas a pulse can actually help the battery heal, I think. I mean, it can break up any kind of crystallization or sulfation or all the different things that batteries can do. I don't know what lithium batteries do, but somehow they can short out inside, and I think it can help break that up. Now, it's not meant to be a battery rejuvenator necessarily. I just want to charge the battery. But if it rejuvenates the battery, that's okay too, right? You know, we tend to talk about the negative all the time, and it's really easy to do that, and it's kind of wired into us like a self-preservation tool, right? Where we can focus on the negative, right? But it's fun to focus on the positive, and the positive is the potential, what we can actually do, what we can actually get what we need. What do we need? If I need fast 5-minute to 10-minute fast charging, how do I get there? I'm not going to get there thinking about the negative. Am I going to get there thinking about all the people that say you can't do that, you're ruining the battery, you're wasting your time? How is that going to get me closer to my goal? What gets me closer to my goal is turning the comments off. Well, the old comments are still there, but I'm not reading new comments right now. I'm focusing on what I'm learning and what I need to do. And I'm figuring out what I need to do in the journey of creating the experiment. So what's the experiment? How do I get to my 5 to 10 minute fast charging? Or how do I trickle charge while I'm riding the scooter? How do I trickle charge that battery to have a range extender, right? It's just a thought. It's a thought experiment. It's something I'm thinking about. Okay, this is going very well. The battery's not getting hot at all. I don't quite understand that. I mean, we're charging at 13 amps. I love how the charger's staying right at 13 amps. Have you noticed that? The voltage is increasing. It's gone up almost 2 volts in the past, I don't know how many minutes, maybe 10 minutes or so. Anyway, I think I'm going to wrap up this video. I was planning to just talk about setting the charger up, but I just love sharing my thoughts with you guys. I love when you share your thoughts and your creativity when you make videos. I want to encourage you to keep on your path of infinite possibilities. Go for it. But remember, safety is the top priority. Always be careful. I do my best to be careful. I make mistakes. I still make mistakes. And but remember, respect what you're doing. Respect yourself. Respect your project. Respect those around you. Love yourself and love people to the greatest of your ability. Let's make life the greatest it can be. That doesn't mean harming myself. It means creating the conditions that allow the greatest creativity and the greatest collaboration to work together. So let's do this together, everyone. Okay, everyone, I'll see you soon. True Zero Emissions.